Welcome to our presentation on Parsing XML. This is chapter 15 in your prescribed book. Before getting into the XML part, I just want to go over some housekeeping aspects. Firstly, MS Teams, please log in before you try and join the meeting. There's two reasons for that. One is I'll stop getting these irritating messages about somebody waiting in the lobby. And secondly, if you're a guest, you can't access the chat and hence the recordings. So please log in before joining the meeting. And just to repeat something I said last time out, you can make your own personal recording of the meeting. If you're using Windows 10, you press the Windows key and G simultaneously. You'll get the recording app pop up and you just start recording and then stop recording at the appropriate time and you will have your own personal recording of the meeting. Then the next class will be in 2 weeks' time and it will be on Tuesday, the 14th of June. That's because the 16th is a holiday, but I will send out the announcement in due course. Then assignment 1, the solutions will be uploaded tomorrow. For question 3, Dr. Pilkington's solution used a method to access the properties of Q standard item in her solution. I've done an alternative solution subclassing the model, which I will upload to the eTutor resources. Both methods are equally acceptable, but I just thought it would be helpful for you to see the alternative way as well as using the method. Then assignment 2 opens on the 27th of June, which is a Monday. However, Dr. Pilkington has said, as for assignment 1, he will upload it a bit earlier. He'll do it on Friday, the 24th of June, after lunch. I don't know what time exactly, but sometime after lunch on Friday, the 24th, assignment 2 will be available. Excuse me. And I just want to give you a little heads up. Assignment 2 is much more substantial than assignment 1. Assignment 1 was a very gentle introduction to COS3711. There's much more substance to assignment 2. You'll need to put a bit of thought into your solutions, and it will obviously take you rather longer than assignment 1 did. So please don't delay starting with assignment 2. Get into it as soon as it's available. Those of you who are in the habit of only starting a couple of days before the closing date, don't do that because you'll have absolutely no chance of finishing. Trust me, there's a lot more substance to assignment 2 than there was to assignment 1. Then as to the content, it covers 3 chapters. That's the regular expressions and validation, parsing XML, and then design patterns. I think it's quite obvious that you will get questions in the assignment that cover all of those. So please make sure you know how to implement regular expressions and validation, how to read and write XML, which we'll cover tonight using both methods, and then all the required design patterns. You will get questions on all of those, and I emphasize design patterns plural. And the design patterns, you won't just get a question that asks you to write the code for a specific design pattern. You'll have to do that, implement the design pattern, but then you also have to integrate it into an application in a useful way. So just make sure you're ready for your assignment. And as before, the best preparation for you to do is to do the exercises. That's exercises 6, 7, and 8. Because if you do those exercises, you will have gone through all the items I've just mentioned for the assignment, and you should actually be able to do all of them quite easily. So I emphasize, please do the exercises. It'll be a very good preparation for the assignment. Then more about the exercises. I'll also upload the solutions to exercises 4 and 5 tomorrow. There was too much code in there that could have been used directly in the assignment. That's why it hasn't been uploaded earlier. Sorry, excuse me. The reason for the delay is there were a couple of students who were given extensions for the assignment because of late registration, but that's all closed now, so we can upload the solutions. And that's all the housekeeping aspects. Any questions on that so far, or anything you want to clarify? Otherwise, we'll get into XML. Okay, everyone happy? Right. Parsing XML. The outcomes, or what you need to know for this, is you need to understand Qt support for parsing XML. You must have an understanding of SAX and DOM parsing in Qt. You must be able to implement parsing using the SAX parser, although there's a little question mark next to that, which I'll get to. You need to be able to generate XML files using DOM, and you need to implement parsing using DOM. So basically, you need to be able to read XML with SAX with a question mark, and you need to be able to write XML using DOM, and you need to be able to read XML using DOM. We'll go through all of those now in a bit more detail. Okay, firstly, let's have a look at what XML is. The first thing is it's a markup language. So I'm going to jump down to the bottom of the slide first, just to go through what a markup language is. So a markup language is a computer language that uses tags to define elements within a document. And for example, the less than, body, greater than sign, and then the same with a slash, and the same with a B, the same with a break, which I hope most of you will recognize as normal HTML. So tag just uses the less than and greater than sign around some text or a name or some characters. And that is what a tag is. Then a markup language is human readable, meaning markup files contain standard words. There's no fancy programming syntax or technical terms in them. It's just normal standard words, so it's human readable, it's easy to read. It's used to format text. When the document is processed, the markup does not appear. That's quite an important consideration. Although you mark up a document, the markup is just used for formatting purposes. It doesn't actually appear in any shape or form itself. Then the most popular markup languages are HTML and XML. And we're looking specifically at XML. Okay, so now that we've clarified what a markup language is, let's look at XML. Okay, XML is a markup language that defines a set of rules for encoding documents in a human-readable and machine-readable format. So that's all XML really is. It's a markup language that defines a set of rules. Okay, this is just some background. You don't really need to know this, but it was originally published in 1998 by the W3C. The latest version is 1.1, which was published in 2006. But rather strangely, it's not actually used very much. It introduced some additions, mainly to do with, I think it was dealing with white spaces, which wasn't particularly popular. And it's really, 1.1 is not used very much. In fact, you'll find that 1.0 is still in general use. Generally, your files, which contain XML, have an XML suffix. XML is commonly used for data storage and communication. It's particularly over the internet. It's used by a large number of applications, including MS Office, OpenOffice, Net, and Qt. Qt Designer stores all your form layouts in XML. An important consideration about XML is that it is hardware and software independent. Data is stored in plain text format. Again, this is something quite important to recognize about XML. It's just a plain text file. There's no fancy code words or fancy formats or anything. It's just a plain text file with basically plain text in it that's been marked up. So this is one of the strong points about XML. It is totally hardware and software independent. It's just a plain text file, generally with an XML suffix. And then this is another important thing to understand about XML. XML doesn't actually do anything. So it's a bit of a strange beast. Don't get the idea that XML is some kind of a programming language or something actually code that runs or does anything. XML doesn't do anything. XML is just data that is wrapped in tags, and it follows a set of rules. There's also no predefined tags. So basically, XML, quite blatantly, you make it up as you go along. But XML doesn't actually do anything. It's just a plain text file, and it's just data that's wrapped in tags that you make up as you go. The only thing is those tags and the way you mark it up follows a set of rules. But XML by itself is not code that's executed, and it doesn't actually do anything. And there's no XML language as such. It's just the rules that are used to mark up plain text. So as I said before, don't get the idea that XML is some kind of a processing language that gets executed. It's not. It's just a set of rules that marks up a plain text file. So that is a bit of a background to what XML is. Don't seem to be any queries. Okay, and looking at some of the terminology, a character. An XML document is just a string of characters, generally using any UTF-8 characters. So as I've said a couple of times already, it's just a plain text file. But the characters within your XML document can be divided into two types. There's the markup, and all markup begins with a less than sign and ends with a greater than sign, or begins with an ampersand and ends with a semicolon. So that is the markup. So those 4 characters. Everything else is content. So that's how simple your XML is, basically. It's got markup, and there's only 4 characters that are used for markup. And then there's content, and that's anything else that's not markup. Then we have what is known as a tag. That's a markup construct that begins with a less than and ends with a greater than sign. So obviously a tag is one of the most important aspects of XML. In fact, it is to a large extent the XML. And there's 3 types of tags. You get a start tag, that's with some characters enclosed in a less than and greater than sign. You get an end tag that includes a / at the beginning. And just note something that I'll repeat shortly. When you have a start and an end tag for an element, the name must be exactly the same in both cases. The only difference is the / at the beginning. But your start and end tag for a specific element must be exactly the same, including the case. You can't have one uppercase and one lowercase. It's case sensitive. And then the third type is an empty element tag, and that just has the / at the end. So there's only 3 types of tags: a start tag, an end tag, and an empty element tag. Then an element is a document component that begins with a start tag and ends with a matching, and I emphasize the word matching, end tag. The only difference being the / at the beginning of the end tag, or consists of only an empty element tag. And an element can have text content and attributes, and we'll look at those in more detail. But the text content is basically what goes between the start tag and the end tag. And then attributes are included in the start tag. An attribute is markup that consists of a name value pair within a start tag or an empty element tag. You can't have attributes in an end tag. It can only be in a start tag or an empty element tag. And according to the strict XML definition, it can only have a single value and can only appear once in each element. In this book with an attribute of type and data of novel is an example. However, there is sort of informal uses crept in where there's multiple values, but that's not the strict XML definition, or you will see it where you have a comma, semicolon, or space. Comma or semicolon between the items or spaces. And this would be an example of having multiple values in the attribute. You don't see it all that often in XML. It's more something you see in HTML. It's not strictly according to XML rules, but you do see it from time to time. And then attributes, what distinguishes attributes from the data is that attributes should contain metadata. It's data about data, not the actual data. So you shouldn't put your actual data to be stored as attributes. They should be the content between the start and end tags. Metadata would be some additional information. One thing you see quite often is things like ID, just to identify that element uniquely with an ID number, for example. But the data itself should go between the start and end tags, not as an attribute. The attribute, if you like, is some additional information about that element. Okay, then carrying on with the rules of XML. Valid characters for XML, all Unicode characters are valid except null. So you can use anything pretty much except null, but some control characters have to be escaped to be used. And we'll look at those next. When I spoke earlier about version 1.1 of XML, some non-printing characters were added in version 1.1, and so they weren't very popular and not universally accepted. So most people have stuck with version 1, but that's all that 1.1 did was to add in non-printing characters. It's like your new line and carriage return and things like that. They're not particularly useful, so I'm not sure why they were really added. But anyway, but in general, you can use any Unicode character except a null. And there's some specific control characters have to be escaped if you want to use them as data. Okay, escaping. I don't know if you can hear that, but that's just my cat coming home. Escaping. Characters that cannot be used directly, which cannot be used, when I say cannot be used directly, they cannot be used as content, and they have to be escaped. And the ones are the less than sign, you use an ampersand, an LT for less than with a semicolon, and that semicolon is important. Greater than is the ampersand, GT for greater than, and the semicolon. The ampersand itself is AMP with a semicolon, apostrophe is APOS, and a quote is QUOT. So if you want to use any of these within the content of your element, you have to escape them, otherwise it will be read as markup. So if you want to put a less than sign in amongst your content, you have to use the ampersand LT semicolon. Otherwise, the parser will try and read that as the beginning of a tag. But these are the only characters that have to be escaped. There's only 5 of them, so that's not a lot to remember. But these are only characters that you can't use directly as data. Otherwise, as I say, it tries to read them as control characters or as elements. Then XML also has comments. Comments can be used anywhere in a document outside other markup. Comments are the same as HTML. It's a less than exclamation mark and 2 minus signs, and it ends with 2 minus signs and a greater than sign. So this is an example of a comment. And then within a comment, you don't have to escape anything because comments are not regarded as part of the document. So anything within the comment is sort of excluded from the document, and you can put anything in there, even the control characters, and they'll be ignored as long as it's within a comment. So you can put comments within XML documents, as I said, the syntax is the same as HTML. Okay, then looking at the syntax of XML, XML document must be what is described as well-formed. That's a term you'll come across quite often. And a well-formed XML document is one that conforms to the rules. And the following are basically the rules. A single root element must contain all other elements. Your XML document is basically a tree structure where you have a parent, child, and sibling elements, and we'll look at examples shortly. But there must be a single root element that contains all the other elements. So you have to have an outer container, which is the parent of your XML structure. Special characters can only appear when used as markup. Those are the ones I mentioned before, plus the apostrophe, which I've left out of there for some reason. So you can only use those characters as markup. Otherwise, you have to escape them if you want to use them within content. Then tags must be correctly nested. You can't have any missing. An opening tag without a closing tag, for example, and you can't have them overlapping. You can't have start tag and a start tag, then the end tag of the first one, and then the end tag of the second one. Your start and end tags must be completely nested and not overlap or go in between the tags of another element. And tag names are case sensitive, and start and end tags must match exactly other than the /, and both are required. It's not well formed if you leave out one of them, and as I said, the name must be exactly the same. You can't have different cases or so on. And then tag names must begin with a letter or an underscore, and you cannot start with the word XML. That's a reserved word. So you can't start a tag with a number or punctuation mark or something like that. A tag name can only start with a letter or an underscore. And tag names can contain alphanumeric characters, underscores, hyphens, and full stops. You're not allowed spaces in tag names in strict XML. Then there's one other item, which is known as the prologue. It's optional. If you do have a prologue, it must be used first, and that's this line with the question mark in XML, which generally just gives information about what version is being used and what is the encoding and so on. You don't generally have to worry about that. Your Qt parsers will insert those and interpret them itself. You don't have to specifically deal with them. I'm just mentioning it here because you will often see those as the first line of an XML document. That's just the prologue, and it's optional. It must be in the first line if that's used. There are one or two other versions which contain, I think, another item of information, but as I say, it's not something you generally need to worry about. That's handled by the system. But you will see that in XML documents. Okay, so far so good. It's all relatively straightforward. Okay, then this part, you don't have to know this or learn it. I'm just mentioning this because this word token appears extensively in the Qt documentation. So I'm just putting this to try and explain what they're referring to when they refer to a token. But a token is a small unit of indivisible character values. It's one of the recognizable things within an XML document. In other words, a start tag or an end tag or an attribute or the content between two tags. It's one recognizable element of an XML document. That's referred to as a token. Now, where these are relevant, when the document gets parsed, particularly with the SAX reader, when it reaches something like a start element, it then creates a token. That, in this case, would be one that's called start. And then that represents the start of an element, and that token is then used for the processing. It creates an event which processes then that start token. So as the XML parser goes through the document and it reaches recognizable parts of the document, things like the start of an element or the end of an element or content or something, it creates a token to mark what that is. And these are the different types of tokens: the start of the document, the end of the document, the start of an element, the end of an element, the text between the elements, an attribute, and so on. And so you don't need to know anything about this really, but just when you read the Qt documentation, you will read about tokens, and a token is just something that's created when the document is passed, and it's just a marker for a recognizable part of the document, things like the start element or an end element or the text or so on. It's just how the XML parser works through the document. It uses tokens to mark the various aspects of the document. So that's all a token is. So you don't really need to know about it, but just have an idea of what it is. And then something I should probably have put earlier, parsing. Parsing means the process of splitting up a stream of information into its constituent pieces. And those constituent pieces in this context are known as tokens. What the tokens identify those constituent pieces. So parsing is just the process of splitting up a stream of information into smaller recognizable parts, and then a token gets created for every recognizable part. But that's what we're doing in parsing. We're just splitting up a stream of information into smaller usable bits. Okay, then we're getting onto the actual XML. All right, this is a typical example of an XML document. Right at the top, you have the prologue, which is optional, but you will generally find that at the beginning or something very similar to that at the start of an XML document. Then your outermost container, which is compulsory according to the rules, is your root element. So in this example, library is the root element. And note you have a start tag library and an end tag also library, just with the / in it. So that's the start tag and that's the end tag. Then within your library, you have its child elements. And the first level here is a book. So a book is a child element of library. Then we have another book that's also a child element of library. And you could have a large number of book elements. And those book elements are all children of the root element library. Then book, in turn, has child elements. In this example, they are title, author, year, and price. So those are all child elements of book. And then within book, title, author, year, and price are all sibling elements. They're all at the same level. They're equals. So you basically have parent, child, and siblings. So title, author, year, and price are all sibling elements because they're all at the same level. They are all children of book in this case. And then we have an example of an attribute which is included in one of your elements. Remember, it's information about information. In this case, we have an attribute named category. You use the equal sign, and its value must be included in inverted commas. You can actually use single commas as well. But that is the difference between an attribute and content. An attribute is included within an element, and it has a name value pair, whereas content is the part between the start and end tags. So that's the difference between content and an attribute. Remember, attributes must be in inverted commas, and it has a name and an equal sign as well, whereas your content is just the actual content between the start and end tags. So that briefly is some of the terminology about XML, but you must understand this very well, as you'll see when we get to the code, because this thing about root and child and sibling and attribute is all very important in the processing of your XML document. And you need to understand how those all fit together, otherwise you can get very confused very quickly. Are there any questions so far? Is everybody still awake?
Hello?
Yes.
I have a question. In terms of the information in the XML file, is this relating to objects that we would have in our code? in the sense of if we would have a library object, a book object with many properties, or what's the utility of this in this
Yes,
example?
you will get examples to do exactly that. You'll have to store an object in XML format, and if you had book objects, this is how you would store them. And you will also get examples where you've got to recreate objects read from an XML file. So if you do the example in the exercises, you will do exactly that, yes. But a book, in this case, can very definitely represent an object, which you'd have to write the object in XML format like this, and you'd also be able to have to read an XML file and recreate the object from the XML. So yes, it can represent an object in your code. It can just represent plain data as well, but yes, in this example, they could very well be objects. Okay, then looking at XML parsers, right, there's two basic types. In fact, really one and a half, I suppose. I'll come to that now. The first one is SAX, which is the simple API for XML, hence the word SAX. SAX is what is known as parse event-driven parsing. I'll get back to that now. Right, it's sequential parsing. It goes in one direction only. It reads a document from the beginning and goes right through until it gets to the end. There's no stopping or any intermediate thing. It reads the document sequentially. It starts at the beginning and goes right through until it gets to the end. In SAX, can process an XML document of almost any size. And the reason for that is that only the current process is loaded and the previously processed portions are then discarded. So it starts reading a document, it processes as it goes, and the part that it's processed, it discards and then carries on reading until it gets to the end of the document. So at any one point in time, it's only actually processing a small part of the document, and it discards anything that it's processed. So there's no going back, there's no editing or anything. It reads it and reads it in one direction only. So SAX can only read XML documents. Now this, in days gone by, would have been a very important consideration because of the memory limitations of computers. This isn't really a limitation anymore any day. So SAX parsing is less important than it used to be. In days gone by, it used to be the only way because of memory limitations, and you needed this kind of process where it only had a relatively small part of the document in memory at a time, and it discarded all the parts it had processed as it went along. Okay, why it's called parse event-driven parsing? Because as it reads through document, it gets to something it recognizes, say like a start tag. It then generates a token, which in turn then generates an event. Those of you familiar with JavaScript will recognize the term callback. So it generates an event on callback. It processes that start tag and it carries on. It gets the content, which generates another token, which generates another event, and it processes that content and so on. It passes through document generating tokens, and as it gets to each token, it then creates an event and processes that portion of the document, and once it processed it, then it discards it. So SAX is pretty efficient for reading, but as it has the limitation of it's one direction only. It just reads through processes and gets to the end. That's it. So SAX is less important nowadays as it was in the past. Then the alternative and more complex method is DOM, the document object model, which does tree-style parsing, right? It breaks your document down into the root and parent and child and siblings and all of that aspect. So with DOM, you have random access to the tree structure. The processing is only limited by the amount of available memory, which, as I said, is not so much of a limitation nowadays. With DOM, the entire document gets loaded into the memory all at the same time. And then because the entire document is in memory at one time, you have random access to its structure. So DOM can then also be used to edit XML documents. And it can also write and also read XML documents. So DOM can do a lot more than SAX. It can read, write, and edit XML documents. You can sort of can read a document, make changes to it, and then write it again. So it does a lot more than SAX does. But as it had the limitation in days gone by of loading the entire document into memory, which in the case of large documents could have been difficult. It's not that much of a problem nowadays. Then one thing you need to recognize about DOM, everything in DOM is basically a node. And we'll have a look at this when we get to the code. You go through and process nodes, and then you have to convert them to elements to process them further. But within DOM, everything is basically considered to be a node. And we'll look at that in more detail shortly. Right, then the classes in Qt, this is for SAX, the stream style parsing. The classes are QXML stream reader and QXML stream writer. There was a class, if you look in the prescribed book, you'll see there's a class QXML simple reader, which used to be used for SAX reading. That's obsolete. It's actually been removed from Qt. So anything you see in the prescribed book about QXML simple reader, just ignore that. It's been replaced by QXML stream reader. Okay, then just a word. QXML simple reader is what was used for SAX parsing. So strictly speaking, there is no longer a strict SAX parser available in Qt. It's been replaced by QXML stream reader. Now, QXML stream reader is a sequential reader. It actually does exactly the same as what a normal SAX reader does. But because of a technicality of the way it processes the tokens and so on internally, it doesn't strictly comply to the SAX standard. So it can't be called a SAX parser because it's, as I say, on a minor technicality, it doesn't conform to the standard. But it actually does exactly the same as a SAX parser. So in fact, we'll be using QXML stream reader as a substitute for a SAX parser. Externally, it's exactly the same and does exactly the same thing. But just as I said, on a technicality, we can't really strictly call it a SAX parser, but it is a sequential stream reader. So we'll be using that as a substitute for SAX. So that briefly is the difference between SAX and DOM. You do need to know about these differences, and we will be coding examples using XML stream reader and writer and also DOM. So you need to know how to do all four of those. Okay, in QXML stream reader, these are just some of the methods that you will come across. You must look at the documentation, and I strongly recommend you do some examples. This parsing XML is not particularly different. It's a bit tedious. It's very repetitive, as you'll see when we get to examples. But once you grasp it, it's not particularly difficult. It's just a lot of repetition and looping through things. But do you have a look at the documentation and get an idea of what these various methods do? Right, the first one is to set your device. Firstly declare your reader, and then you set device, and that generally would be the file that you're going to read. So you would open a file and then set that as the device. And here's an @end method, and you use that in a loop. Remember, I said a lot of this processing is repetitive. You go through loops, so you generally would have a construct like this, while not reader @end. In other words, just keep looping until you get to the end of the file. So that is something you will use quite often, this @end. Then read next. reads the next token and returns its type. Those of you familiar with Java, it's a Java type iterator. When you start your document, the marker is put before the first item. And then when you read next, it moves the marker to that first item. And thereafter, when you read next again, it moves it to the second item and the third item, and so on. But that's how you access the various items within the loop. You keep looping until you get to the end, and you use read next to step to the next item, and that returns it reads the token and returns its type, things like start element and end element and text and so on. Then Qt provides more useful items like isStart element, which returns a bool type and returns true if the token type equals a start element. So this isStart element is just a wrapper for if element type is start token. So generally, when you do processing with XML Stream Reader, you don't actually need to access the token types at all. Qt does that for you. You have these convenience methods, things like isStart element, which does that for you. That actually checks the token types internally. You will actually never need to process the token types directly. Then once you've found an element by finding a start element, you can then access its name with the name method that returns the name of a start element, or in fact of an end element of any element. And just notice that a return type is a QString reference, which is a slight complication, but it has a toString method, so it's actually quite easy to convert it to a toString. Then you have a read element text that fortunately returns QString that returns all the text between the start element and the end element, and that is the bit you actually want, because that is the content, that's the actual data. So the element text is the part that you want. And then another important method is end element, which returns bool. Basically, once you get to an end element, you've read through all the siblings within a particular object, and you once you get to the end, that is then when you need to process all the content that you've drawn out of that particular element. Then attributes, there's a separate class, it's an XML stream attribute. You access it with the attributes method, and that returns the attributes. You have to loop through that. I'll go through an example, and then from that, you can draw its name and the value. Remember that attributes consists of a name and value pair. Again, those come out as string references, which you have to convert to string. So attributes, you read all the attributes using this attributes method. That QXML stream attribute is basically a list that you loop through, and you draw the name and value pairs. Then there's also methods for error processing, has error and error string and so on, which if you're quite diligent, you should include as well. So I'm just giving you an idea of some of the methods that you will use in QXML Stream Reader. But the best way to get to terms with this is to actually do an example. Then you'll see what all these methods actually do. It's probably a bit difficult to grasp just looking at a list of them, but this is just an idea of the method names that you need to have a look at. It would be beneficial to look at the Qt documentation to get a better idea of how these all fit together. Okay, then looking at an example, this is QXML Stream Reader. Okay, I haven't shown it here, but the first thing you do is open your file in the normal way. You declare your file and open it. That would happen before this code that I'm showing. Okay, you declare your XML Stream Reader. We've called it Reader. You then set device to the file that you've previously opened. You then read next. That moves the marker to the first item of the document. You then loop through the entire document. So you say, while not reader at end, in other words, while there's still content. And then you basically got to pick out all the useful bits of information as you get to them. So you'd say if reader is a start element, right? So you want to know if it's a start element because that's where your content is. Sorry, I'm just going to skip ahead here. I'll come back to this. This is actually the document that we're looking at. It's just a simple XML document. The root is catalog, and then within the children of catalog is CD, and each CD has a title, artist, and year data member. So we're going to be looping through this document, looking at CD, title, artist, and year. So it's just a very simple example, just to give an idea of what we're actually looking at. Okay, so we're looping through. We've said while not at end. Okay, we're saying then if it is a start element. So we're not interested in, at the moment in anything else other than a start element. Once we reach a start element, we want to have a closer look at it. Then we say if the reader name to string, remember we have to convert it to a string, is equal to title. Right, what this probably isn't a great example because we should in fact have looked for the start element catalog first. You should always check that you are actually reading a document of the correct type. Remember XML, when you pass your document, you actually need to know the actual structure because you're looking for element names that you know. So we should in fact have looked for the root element first, but I left it out of this example. So we should actually have checked first for catalog and only continued processing if we knew that we were looking at a catalog document that contains CDs. So your first item here should actually be checking for catalog, but I'll keep it simple, so I've left that out. So the first element that actually contains information that we're looking for then is a start element that's named title. So once we find one for title, first thing I'm going to do is look for the attributes. And this attributes method returns a list of all the attributes. So we just call attributes on the reader. The return type is a constant QXML stream attribute. It's basically a list. We just use a for each loop then to go for it. We say if the attribute name to string is equal to type, we get its value using the value method, convert it to string. So now we have the attribute value. We can also get the attribute name from attribute name to string. At this stage, you would do something with that name value pair, store it in some useful way. I'm not showing that example, but this is how you would recover the attribute name and the attribute value. And then what we haven't done yet is to get the data of this title element. We just call the read element text method, and that gives us the data content that is between the start and end tags. And something else I should have mentioned, this title, would be a Q string that I've declared outside of the loop. I would have declared it for title and artist and year. Oh, sorry. Mouse is too sensitive. Okay. Yeah, so you declare variables to store your information beforehand, but here we're recovering the title. We're just saying it's reader, read element text. Then continue to say else if the reader name to string is an artist, then we do exactly the same. We recover any attributes using that same for loop. And then the artist data, we read element text for artist. And then the same thing for year. It's exactly the same loop again to get the attribute values. And once again, we get the year data, reader, read element text. Remember, this is for a start element named year. This is what I said previously about being very repetitive. You just loop through testing for each possible element name, and once you get to one you recognize, you then extract any attributes and you extract any data content for it. So it's just repetition, repetition, repetition. So that's all the start elements we're looking for. Remember, we're still within our main while loop. So the next thing we're looking for, we're saying if we add an end element, and the reader name to string is CD. So we've now found the end of a specific CD where we would have extracted the title, artist, and the year for it. We now have all the information for a complete CD, which we want to process. In this case, I previously declared a CD would probably be a string list. Sorry, I should have put more detail in here. We're just adding this information that we've extracted for a specific CD into our main holder of probably a list of some sort. But you could do any kind of processing at this stage. For example, going back to that question we had earlier about reading objects, if you wanted to instantiate objects, it's at this point here where you would instantiate the object and probably add it to a list of some type so that you can retrieve all the objects. But it's at this point that you've got to process the content for a specific item that you've read from the document. And once we've processed the end statement, then we just go to reader, read next, and we go back to the top of the while loop. And once you've finished all of that, you close your file, and then we return the container that contains all our information. But it's quite simple. As I say, the actual code in this example for here, it's just the main thing is the loop to get the attributes and then just getting the data for the year. And you just repeat that identical code for every element within the XML document. So the actual unique processing you're doing is very small. You just have to repeat it and repeat it and repeat it and repeat it for every element. The only thing that really changes is the element name and the attribute name. But all the rest of the code is just repetition all the time. So it's quite laborious. And it's just looping, continuously looping through the document until you've processed all the content. But to get to terms with this, you really need to do an example. It's not actually very difficult, but I think it's just a matter of getting an example and you'll see how it all fits together and works. It can be a bit confusing at first, but it's not particularly difficult once you've actually had a closer look at it. Okay, any questions on XML Stream Reader? Okay, so it looks like we're going to get good marks for assignment 2. Everybody knows what's going on. Okay, DOM. Okay, okay, we've looked at an example now about reading XML. Now we're going to look at writing XML. But DOM can also be used to read XML. Okay, some of the classes used with DOM is QDOM document, which is the main one, QDOM element, QDOM text, and QDOM node. And I'm actually going to start at the bottom here. QDOM node is actually the main class for elements and text. Pretty much everything in DOM is a node. So QDOM text and QDOM element are actually subclasses of QDOM node. But just remember this as we go through an example, you'll see that everything in DOM is basically a node. Okay, the first thing you do then is declare your QDOM document and you give it a name. That is the constructor, but you have to start with an actual document. Then you have methods like create element, which you give us a string name. Then append child adds elements or text to your DOM document. And then create text node. That's the data content between your start and end tags. That creates the element text. And then set content is an important one. It's used to parse XML when reading a file. So the first thing you would do when you're reading is you instantiate a QDOM document and then set content. So it knows which content to pass. Then with QDOM elements, again, you append child and you give it a name, and that's how you add a node to an element. For attributes, you set attribute, you give it a name, a value pair. That's how you use to set attributes on your elements. And then the DOM text, you create a text node. That's just the string, which is the content. And that's how you create the text for your elements. So these are the methods that you will deal with most often, but we'll have a look at an example. But again, look at the documentation. But these are the methods that you should be looking out for. Okay, as before, this is the example. We're looking at a little CD catalog. Okay, then starting with your DOM processing, the first thing you do is instantiate a DOM document. You'll find it's very commonly called doc, which we'll stick with in this case. Then you instantiate a DOM element. And this is going to be our first one. We call it the root element. Then within our root element, we say root element is equal to the doc. Remember, we're creating this on the overall document. We create element catalog. Right, that's our root element. Then we take our document and append the child to it, which is the root element. So here we've instantiated a root element, a QDOM element, which we call root element. Then we've said the root element is equal to create element named catalog. And then we've appended that to the DOM document as a child of the DOM document. So we just append root element as a child to the document. And as we'll see over the page, it's just repetition of this all the time. You create element, append it, create an element, and then append it. So we repeat this for each entity in our XML document. You can either use a function, which you can call repetitively, or use a loop. So here we're now instantiating a DOM element called CD. We create an element within our doc called CD. We give it a title, a doc create element title, DOM text. We're going to give it content. We call it title text. We call create text node on our document, where we give it a name to our title. Then we create a DOM element named artist, which we call the create element on our document, name it artist, and so on. So it's all just repetition. You create the element and the text content, create the element and the text content, create the element and the text content. Then this is the part where it gets a bit tricky. You need to make sure that you append the child to the correct parent. Sorry. Okay, sorry, my mouse is a bit sensitive. Okay, so we have our root element that we declared previously, and we append the child, the CD element. Then on the CD element, we append the child title. Remember that structure of the document we had at the beginning? Then for title, we append the child of its text. That's the content. Then on CD, we append the child, the artist. That's the element. Then for the element named artist, we append a child, and that's the text. That's the content between the start and end tag. And then on our CD element, we append another child, which is year. And for year, we append a child called the text. So I'm just going to go back to the document. So for CD, title is a child of CD. For title, the title text, in this case, title 1, is a child of title. That's the content between the start and end tags. Yeah, so when we said CD append child title, we were appending the start and end tags title. And then within title, we appended the child being the text, and that goes between the start and end elements. So it's just a matter of creating all the elements and their content, and then appending them in turn, and just making sure that you append them to the correct parent. That's the tricky part, is knowing which parent to append which child to. And this is the part that takes practice. In looking at attributes, you should not use attributes for data. They provide additional information, that's metadata. And the way you add attributes to DOM is you create a DOM element. In this case, I'll just call it element. This is a person. Then on that element, you call the set attribute method, and you give it a name and a value. You set attributes with a name and a value, set attributes with a name and a value. And then you append that element. In this case, it's to the root. So that's how you set attributes. You just call the set attribute on the element. And this is what it would look like in this case. We created an element named person, and then we set attributes of ID, age, and phone number. And so that is how attributes work. It's actually quite easy to do. I'll get to the question shortly. Just hold on. So setting attributes is quite easy. It's just a set attribute method with a name, a value pair. Okay, carry on with the question. Sorry, wasn't it?
Hi, Bernard.
Yes.
I wanted to ask, the way we pass attribute, is it like is it like a tree? The way that we pass this attribute?
Is it like?
A tree, from the parents to child.
Yeah, the attributes is not so much parent-child. All the other elements are parent-child.
Okay, okay.
Yeah, in this catalog, catalog is the root. In CD is a child of catalog.
Yes.
Title is a child of CD. Artist is a child of CD. But title,
correct.
Artist, and here are all siblings. They're all at the equal level.
Oh, okay, okay.
So yes, it is a tree structure, but you have children and you have siblings and a parent or a root.
Yes, correct, correct. Okay, thank you.
Yeah, so setting attributes is quite easy. Remember, the attributes appear within the start element tag, as opposed to your data, which goes between the start and end element. But that's all you have to do to set attributes, is just call that method with a name value pair. It will also accept integers, which is why I specifically showed it like that, but it still puts them in the inverted commas for you. In fact, if I'm not mistaken, I'll speak on the correction, but that value is probably a Q variant, but just check the documentation. But yeah, when you're setting attributes, you don't necessarily have to put everything in inverted commas, unless it's a string, which you do have to, of course. But it probably is better to put it between inverted commas. But anyway, that's how you set attributes, and that's how attributes come out, as opposed to the data between the start and end tags. Okay, just going to catch my breath quickly. Any other questions? We'll have a quick look at reading DOM. So this isn't particularly difficult. It's just very tedious and repetitive, and you just have to get used to the structure of it. And if you do an example, you'll see it's actually quite easy, but it can be a bit daunting at first look because there's quite a bit to take in. But it's not particularly difficult once you get to used to the repetitive nature of it. Just create an element, append the child to the parent, create an element, append the child to the parent, and so on. Or when you're reading, you just go through a loop, searching for each type of a tag in turn and drawing out the name and the value. And you just keep processing like that until you get to the end of an element. Then you process all the data items you've pulled out, and then you skip to the next item and go through, just keep on going through the loop. It's just repetition, repetition, repetition. So it's not particularly difficult once you grasp it. There are quite a few method names to get used to at first, But once you grasp how it works, it's actually not very easy. I mean, it's not, whoops, it's not very difficult. It's just very repetitive. Okay, then reading DOM. Okay, as before, you would open your file first. I didn't have enough space here to show that, but I'm sure you all know how to open a file. So going through here, we're going to assume that the file is already opened. Right, then as before, you declare your DOM document. It's generally called doc. It doesn't have to be. You can call it any name you like, but most examples you'll see will do that. Then you set the content to the file that you've opened. That's the file you want to read. And doing this setting content, it actually reads the content of the file for you into memory. So all you have to do is open the file and then set content, and that will automatically read the content into your DOM document for you. Okay, you then declare DOM element. This is because it's our first one, we call it root, and that's equal to a document element. Then the first thing we want to do is check that it is the correct list that we're looking at. And so you should always check your root element. If the root tag name, that's a method you use to read the tag, is equal to catalog. If it's not catalog, this is reading the same example file that we looked at previously. Remember your DOM or XML parsing is structured specifically for a particular XML file structure. So you don't want to be looking at a file that's got a different or incorrect structure in it. So we only want to parse this if it is in fact our library catalog XML that we're looking at. So you should always check the root tag name first and make sure that we're processing the correct document before going any further. Then the next thing I've done is to declare some variables to store the content that we're going to be retrieving. So this is the same CD example where we're going to retrieve information for CDs with title, artist, and year. And we then carry on. Remember, everything is basically done with a node. So we declare QDOM node, which is the root's first child. So we want to look at the first CD. Then we set up our loop while the node, node is null. So we keep on looping while there is content. Then we get to the actual parsing of the XML. So we want to look at the elements. So we declare DOM element, and we use this node to element method to do that. So remember the actual basic processing we're doing is on a node, but the nodes are not that useful to us. We've got to convert them to elements. So what we're doing is looping through the nodes, but as we get to each node, we create an element to have a look at, because elements are what we process. And then we say, if the element's tag name is equal to CD, then we know that we've got to our first CD and we want to process it further. Remember, the CD is the main structure. We actually want to look at the children of the CD to get the title, artist, and year. So again, we want to look at the first child of the node. We don't want to look further at CD because there's no further information there. We want to look at its children. So again, we go to first child, and then we set up another loop, basically to loop within a CD, so we can read all the children of CD. So we keep looping basically between our CD start and end tag until we've looked at all the content, while CD node is not null. Okay, so again, we created a CD element. We call the toElement method on our node, and we check in if CD element's tag name is title. That's the one we want. So then we draw the title information. We use the text method, which returns the data. That's the content between the start and end tags on our CD element. We store it in our title variable that we declared. We carry on with our loop we say if the CD elements tag name is artist, that we then recover the artist information, again by calling the text method. Just hold on with the question, I'll get to you. And then likewise with the year, when we get to a tag name that's named year, we draw the year data by calling the text method on that specific element. Then we've now recovered the title and the artist and the year, so we then move on to next sibling. And just remember, each of these title, artist, and year will be recovered on succeeding iterations of the loop. So the first iteration, it'll record title. It'll then go through the loop, next sibling, back to the top. The next one will then be artist. It'll then get down to next sibling, go back to the top of the loop, and then it will recover the year. So remember, it takes 3 iterations of your loop to get here. It doesn't recover all of those at once. It only looks, your marker in XML document is only looking at one element at a time. So to recover this information takes 3 iterations of your loop. Just bear that in mind. This is not all recovered at one time. And so I just want to show you what this, oops. Remember, we've got 2 loops here. The one is on outer document looking for CDs, and the other loop is within CDs. So there's 2 loops we're going through. So when we get to the end of the second one, we finish going through all the CDs. Hello. Sorry, my cat has now joined me on the desk. Kitty, just mind here, please. So we finished looping through everything. We now want to process the input. This CD here would have been a string list that I declared up at the top. I should have included that. Sorry, wait, I'm getting mixed up. No, CD is a string variable that would have been declared outside. We just set up a string that includes our title, artist, and year information, and then append that string to list, which would be a string list. Then something I haven't included here is to clear the variables, so I don't have space. These variables, title, artist, and year, you should set them back to empty strings, because you will get cases where when you loop through here, you don't necessarily use every one of those on every iteration, and you might end up inadvertently posting obsolete information into your data structure. So you must clear the variables at the end of each iteration. Sorry, then that was all on the inner loop. Then we get to the end of the outer loop, and we go back to the next sibling again for the next CD. So that's all it is. You just set up generally a pair of loops, depending on how many layers of parents and children you have. And you just keep on looping through them until you've processed every item. Then at the end of the loop, you process your data that you've recovered, and you move on to the next item. And then at the end of that, again, I haven't shown it here, you would do something with that list, either return it or display it or something like that. This is basically just how you recover all the data. At the end of all of this, of course, you want to do something useful with it, which I haven't actually shown. Yes, sorry, the question? Anyone with a question? Yes,
Yeah,
carry on.
sorry, thank you. Would you be able to just give an overview of what was actually done for this DOM reader? Because I feel like I got lost in all the detail of it.
Okay, what we were doing is we had an XML file with this content here, which, oops, sorry. We had an XML file with this content, which is a catalog of CDs. So we've got a root element of catalog, and then within the catalog, we have CDs, which have child elements of title, artist, and year. And then you have multiple CDs within that catalog. What we did with the DOM processing, and I'll have another look at it, we went through it looking at each element. We checked that the first element was catalog, because if it's not catalog, then we're looking at the wrong file and something that has not got a correct data structure, which we wouldn't be able to process. So the first thing we did was to check that the first element was named catalog, in other words, our root element. Once we were happy with that, we then stepped into it by reading the next item. We then checked that it was start element named CD. We then used next child to step down a level, and we then looped through repetitively looking for an element named title, and we then drew the content out. We then looped through again looking for an element named artist. We drew the artist data out. We then looped through again, looked for an element named year. We drew out the year data. We then wrote those three into a string, which we then stored in a list. We then got to the end of the loop, went back up to the main loop. We found another element named CD. Once we found one CD, we stepped down to find the next child. And again, we went through that same loop again, picking out title and then artist and then year. And we carried on the inner loop and then the outer loop until we ran out of CDs. We got to the end of the loop and then we processed all the information. And that is basically what we did with the DOM document. If I look at this code here, we found the first document element. We checked if its tag name was catalog. And if it wasn't called catalog, we just skipped the whole loop. Then within catalog, we then looked at its first child. And we went through the first child. We looked for one called CD. Once we found CD, we then declared a new node and looked for its first child and declared another loop. This is now the inner loop. And then we looped through looking for elements named title, drew its information. And we looked for an element named artist, drew its information. And then looped through looking for an element named year and drew its information. And there's the next sibling loop. We just went through that until it was null. We got out of there. We now had the information for one CD. We gathered the title, artist, and year together into one string, and we then appended that string to our list so that we could use it later. That took us to the end of our main loop. We went back up to the top again and looked for the next CD, and we carried on doing that until we ran out of CDs. And as at the end here, we should actually do something with the list of data that we've recovered, but I haven't shown that here. Okay, there was another question.
Sorry, would I just be able to ask, just specifically where it said you do QDOM element, CD node, full stop 2 element, what is that line doing? I feel like that's the most confusing.
Sorry, which one? Say it again.
That's just the first line on this page.
Okay, the QDOM element, right? We are declaring an element. Sorry, I'm going to go back a step. Okay, first of all here we found one called CD. So we now know we're within CD and we're looking at its first child. So we're looking at the children of CD, which we know are named title, artist, and year. So we declare DOM element, which I've called CD element, and we use the CD node to element method because we want to convert our current node to an element. So all we're doing is the current node we're on, we're converting to an element which we call CD element. So we now are dealing with an element that we know is part of a CD.
And what is the difference between a node and an element?
A node is what DOM uses internally to process. As I said, everything in DOM is a node, but what we need to use when we process XML is an element, and that is the start and end tag and the content between it. So we basically convert a node that's used internally into an element, which is something that we use externally. So we're just converting the internal node to an external item that we can process directly.
Mhm.
It's
Thank
just changing the internal form to an external form that we can use. Because nodes we can't really use directly, but elements we can, because elements is part of XML.
Thank you very much.
Okay. Were there any more questions? Sorry. Okay, there'll be a slight pause while I read all these questions. Sorry, I'm distracted. My cat's lying right next to the keyboard here.
Sorry, just leading
Can
on.
the empty element tag have an attribute? Morna, I think so. Best thing is check it yourself. I'm pretty sure it can be. It can. Why not use attributes instead of children elements? Jack, yes, you can. It's possible. It will accept it, but the principle is wrong. Attributes shouldn't be used for data. Attributes should be used for metadata, for additional information about the data, not the data itself. But physically, you could actually put the data as attributes. It will accept it and it'll run without a problem. But in principle, it's not the correct approach. Stanley's question, can you give an example of something that needs to be an attribute that couldn't work as a child element? Okay, it's a toss-up. It's not always easy to distinguish which is which. Something that is used more in HTML than in XML is something like an ID, which gives each element a unique identity, which allows you to process it further. And it's not really, in that example, it's not really data itself. It's something that identifies your data. So that's something, best example I can think of offhand. But yeah, this distinction between data and attributes is not always very clear. It's probably a bit of an art to distinguish it. But generally, your out-and-out data should be between the start and end tags, and additional information should be between or put as an attribute. Okay. Okay, Hannah's question, I think I've answered that. To element, all that does is change the internal node to an element, which is something we can recognize and process. Okay, I don't have a camera here, but she's lying right next to the keyboard. She lies right next to the fan where the warm air comes out. And unfortunately, she rolls over every now and then, starts pressing the plus and enter keys. So if you see strange things happening, it's just the cat moving around. Jonas, I'm trying to... XML. XML is a means of communicating or storing data in a human and machine readable form. It is, when you want to communicate data across the internet, it's often put into XML format. For example, the prices on the Johannesburg Stock Exchange are transferred to various clients who use the service as XML. Common use as well, weather report data is also communicated as XML because it's difficult to communicate that in other formats. But XML, yes, it's for storing and communicating data in a format that's both human readable and machine readable. Okay. Okay, Leander, just to add to your answer there, okay, it's not always stored in a file. It's actually communicated to a device. The device doesn't have to be a file. It can be directly through the internet or anything that considered a device. But stored in a file is one way of doing it, but it's not necessarily the only way. Yes, Mona, Qt does indeed store the designer data in XML format. Visual Studio does the same as well. Okay, Joel's question, XML and JSON, yes, they're very similar. I have in fact suggested to Dr. Pilkington that we include JSON in this part of the syllabus in future years, and he's considering that, but yes, they are very similar in use and sort of structure. I'm not sure offhand of what the advantages or disadvantages of either are. Except to say that XML is a much older and long-standing, and JSON is pretty much a new kid on the block. I suppose, and I'm guessing here, but I might say that JSON is, yeah, it's a newer implementation of XML that probably has some advantages. But yeah, they're very similar in what they do. Okay. Sorry, is there another question? I'm not sure why there's a... Okay, have somebody with your hand up, ask a question.
Okay, sorry. Can you just show the code of your write XML? Write XML?
Sorry, can you speak up, please? Can't hear anything.
Could you please show the encode fragments for the write XML again?
This one, the DOM. Yes.
Yeah. Thank you.
Okay. All right, I'll just leave it there so you can look at it. Okay, error handling. Okay, the question about error handling. I did at the beginning show you some methods for handling errors. I haven't covered the code. You'll have to look that up yourself in the documentation. As in, if the XML file was not the correct one, okay, that's not actually an XML error. All you would do is terminate your loop and return your method if it's not the correct file. You just simply wouldn't begin processing the file. So that's not a more file error than an XML error. Yeah, if it's not the correct file or the catalog as in the example, yeah, you just stop processing and go back to wherever you came from. Yes, Mornay, you can indeed use external applications to check that your XML is well formed. Jerry's question, does XML have ability to convert object class to XML? Yes, that ability is you sitting behind the keyboard, and there's no shortcut for it. You have to do it the long way. In fact, that's what you'll get questions in your assignments and exercises exactly to do just that. So I suggest you practice it. No, there's no shortcut. You have to sit down and type it out yourself. Okay, guys, we're more or less at the end.
Sorry,
was there another question?
Yeah, please. Is there a way to, or some sort of equivalent to a find method, or do you have to loop?
In DOM, there would, because you have the whole document in memory at a time, you do have the ability to find specific methods. Generally, but if you want to use it for other purposes, like you're suggesting, it can do that, but you're going to have to look that up in the documentation. But
Okay,
yeah, part of the advantage of DOM is it can be used to edit documents as well. So you can load the whole document and then search through it and find aspects of or parts of it of interest. Can be done, but yeah, it's not the example that we were doing here tonight. Okay, some of the kind of questions that you get in past papers, and these are available on my Unisa. In this question of October 2019, you were given code written using XML Stream Writer. You had to write out the actual XML code that was produced. So you needed to understand how XML Stream Writer works and know what its output would be. Then in January, February 21, they were given the opposite. They were given some XML code, including the attributes, and then you had to write the DOM code that would read the XML. So you need to know this both ways. You need to know how to produce XML code, and you need to produce the actual code that, the actual XML that could be produced by a code snippet. And you need to be able to read and write DOM as well, and then read using the stream reader generally. So your questions can come different ways. You need to understand being able to write code and know what code would be written, and then you need code XML, and then you need how to be able to write code that can read given XML. Okay, some things that you should be doing. You must have a look at tutorial letter 105. There's some additional information there. Exercise 7, I suggest you do. There's an example here of reading using the SAX XML stream reader and then writing using DOM. Then look at the past paper, November 2019, question 3.1. There's some DOM code that you can write there. That would be a good example to do. And then examples reading DOM. You can make up any XML file, or you can download from the internet. You'll find plenty of them, including attributes, but just practice writing code to read an XML file using DOM. And then you must also have a look at doing examples where you use properties, where you use reflection, and then write output to XML using DOM or Stream Writer. And to follow up on one of the questions that was asked tonight, you should also make sure that you can use examples to read XML and then recreate or instantiate objects from the code that's written. And there is an example in the exercises to do just that. I don't think it's in exercise 7. I think it's in one of the later exercises. But yeah, you must be able to recreate objects from XML code as well. And that basically is it, guys. But I really suggest you do the exercises, read these tutorial letters. Don't leave out the prescribed book. It's not necessarily the easiest to read, but there is bits and pieces of useful information there. Look through the past papers so that you get an idea of what you're going to have to do for exams. And just remember, for the assignment, you will definitely get a requirements and example question, where you have to read and write XML. So I suggest you practice, because it is something that's quite time consuming. As I said before, it's not that difficult, it's just very repetitive. But once you get used to it, it's actually quite easy, but it can be quite time consuming. So just make sure you know how to do that before assignment 2 comes along, because assignment 2 is going to take a lot more time than assignment 1 did. Okay, that's the end of the presentation. Any further questions? The recording will be available in the chat to the meeting. I will put the link in the discussion forum for these classes as well. Sorry, cats. But you all are part of the MS team, so you shouldn't have any problems in accessing the recordings. Okay, that's it, unless there's any further questions. Thanks, guys.
Thank you.
Thank you.
Thank you very much.
Thank you.
Thank you, thank you.
Thanks.